Starting. All right, so this is day 3 of 4.07, arc length and sector area. So we're going to calculate both of those. Pretty simple formulas, and of course, we're being recorded. Right. Did I put these formulas on your formula sheet all of you downloaded? It is on there? Okay. All right. All right. So two formulas. The first one is the arc length. This is S equals R times theta, where S is your arc length and S, so this piece, this little section, this would be the arc length I'm pointing to. That would be S. Your radius, of course, no surprise. This is your radius from the center out to an edge. And then your angle of your sector, it's theta, and important, make sure it is in radians. This is important. I would say probably most formulas deal with um, radians over degrees. I would say most of the time, but not always, of course. All right, and then sector area. This is the area of, well, this little piece right here. This would be your area. The shaded portion, if it was shaded, is 1/2 times your radius squared times theta. All right. All right, so let's do number 1 together. So we want to find the arc length. The given radius is 16 feet, and your theta is pi over 2. All right, so what we're just going to use this formula here. We're given the radius, we're given theta. So we just plug those in and we type that in. So everyone go ahead and type in 16 times pi over 2. You can probably do it in your head too. I think this one's actually rather easy just to look at and know what the answer is. Yep. 8 pi. 8 pi. No typing needed for this problem, it looks like. 8 pi feet. This does not say round to the nearest tenth. Your quiz or test may say round. If it doesn't, you probably want to leave it in this exact form, just 8 pi feet. All right, everyone do the remaining 3 problems on this page. I will give all of you, I think, 3 minutes should be good, right? 3 minutes, I think, is fine. Do all of you like the dark theme of this presentation versus the light theme? Me too. Makes my eyeballs hurt less. Yeah, if you're somebody who likes to snip this stuff and print it out, you're going to use a lot of ink for this. Um, if you do that, you can always message me and I can send you the original PowerPoint. You can change the theme to like a white theme if you plan on printing it for whatever reason. You could inverse it, sure, but then that just takes work. Yeah, if you inverse your own Windows, you inverse, and you can do that by doing Windows key I believe. Um, You have to first open up the magnifying application. But yeah, inverse I, and then you can do a snippet of the inverse, and it actually saves the inverse to whatever you paste it to. So that would work. Control Alt I after you open magnifying glass. We got another 47 seconds left. All right, everyone, what is the final answer for number 2? Final answer. 13 pi over 4. Seen a lot of 13 pi's over 4. Yeah, I agree with you. Yep, 13 pi over 4. Nicely done, everyone. Yeah, don't forget, this is in inches. All right, number 3, what is the final answer? 2100, 35 pi over 3, 2100. Hmm. All right, let me go. So looks like we're split half and half between two different answers. All right. So on this previous page, if you notice, and I did state it, I said your angle in radians. It doesn't say, oh, by the way, you can use degrees if you want to. No, it says in radians, which means you have to, well, have it in radians. So if you're given degrees, you have to probably convert it to radians. So again, your angle must be in radians, not degrees. So if you got tricked by this, gotcha, and you probably won't do that mistake again, which is good, right? Which is good. I think it's important to learn from your mistakes. So it is not um, 210. The radians is 7 pi over 6. So now you can probably see why I put these boxes here, just so I wouldn't, um, I guess, give you a hint. I was trying to disguise it. I know, tricky. So, people who got 2100 can probably just easily, quickly just replace their 210 with the actual radians and then do the math, and you will get this answer 35 pi over 3. So 35 pi over 3. Did anybody actually get that answer? Because I saw the two answers I got were not this. Um, looks like a couple people did. Actually, nobody. Nope. Looks like George did. Yep. George got it. Jacob got it. Emily. Yep. A few people did. I'm still scrolling up to see if anybody else got it right. Just those people. Looks like now I got it. Well, yeah. Once you know the little trick to it, right? Once you realize your mistake, like, oh, of course I knew it was radians. All right. So with all my talking about number 3, all of you should have had time to redo number 4. And what did all of you get for number 4? 50 pi over 3. 50 pi over 3. Looks like a lot of 50 pi's over 3. Yep, that's what I got too. Nicely done. 150 converted to radians is 5 pi over 6. That conversion, everyone should know how to do that conversion. It's just top of your head, which of course is multiplying by pi over 180. Why are your hands so cold? Well, you could be anemic, low iron, low blood pressure, low fluids. There you go. That's those are, I think, common reasons. You're welcome, from Dr. Gerald. Jack of all trades, master of nothing. All right. Word problem. Volunteer. Who wants to read this for us? Because I obviously can't read. Dianica, go for it. Julie, you got the next one.
Okay, you have asked your landscaper to create a garden area in an oddly shaped corner of your backyard. Regarding the fencing on the 2 sides of the corner as being radii?
Radii.
Oh, you walk in an arc from wall to wall 20 feet. The number of degrees walked is 80 degrees. What is the length from the back corner to the edge of the garden's arc edge? Round to the nearest tenth.
All right, thank you. Yeah, so radii, you can say, let me read that part again. So regarding the fencing on the 2 sides of the corner as being radii, so it's just, you're in the corner of the yard, and the 2 fences that create your boundary, those are the radiuses. Plural radiuses, plural radii. You can actually use both, just like cacti and cactuses. Those are both acceptable for plural. If you didn't know, yeah, cacti and cactuses, those you can actually use either one. The more you know, right? Ooh, yeah, radii does sound fancier. You're right. Cactuses is correct. Yep. Rhombuses and rhombi. I don't know. I would assume so. I haven't looked that one up though. Maybe when you guys get time, you can look that one up and let me know. I would say probably. I don't know. I never heard plural rhombus as rhombi, to be honest. All right. So in this word problem, what do we know? So obviously, to find the arc length, we have to have these, r, theta, s, at least 2 of those. So what do we know? We know the length is 20. Okay. What else do we know? Degrees is 80. Okay. Yep. So we know the degrees is 80 degrees, and the angle, I'm sorry, the angle, the sector length is 20 feet. Do we know what the radius is yet? No. So, then that's what the problem is telling us to do, right? It wants us to find the length from the back corner to the edge of the garden's arc edge. So that's the radius, right? So let me just kind of draw a picture. Maybe it'll be a sad picture. I don't know. So of kind of like what's going on here. So let's say, here's a fence. Oh, that is not my pen tool. Let's try this again. So let's say, here's a fence, and then here's another fence, and then you have this sprinkler head right in this corner, right? And it sprays, and if you could visualize a sprinkler head spraying water, it's gonna, if it's in this corner, it's gonna spray this arc like distance, right? So this would be the radius to that point, which is one of the walls, right? This would be the arc length S. And what else do we know here? Oh, and then the degrees is this is 80 degrees. So that visually that's what's going on, right? And then there's you, stick figure, and you have no arms. So just like last time. All right, so we have to set this up. All right, what should we do first? Very good. See, you guys have learned your lesson. We have to convert to radians. Yes. So what is 80 degrees in radians? 4 pi over 9. I'll take your word for it. Yep, 4 pi over 9. Yep. So we're just going to plug this stuff in. So what goes first? What should I write? R. I think that's an excellent start. Whoops, not R. You mean 20. Because at the formula, S is first, right? We just, all we're doing is plugging the stuff into here, right? So S is 20. And then what Antonio says, then your R, and then your angle. And we're just plugging the stuff in. Okay, everyone go ahead and solve this. The rest of it, I'm going to set a 30-minute timer. Oh, or sorry, not 30-minute. Haha, that would be too long. We would all fall asleep. 30-second timer. Ready, go. Solve for R. All right, time is up. So what is your final answer rounded to the nearest tenth? So we got a 14.3 feet. 14.3, got 45 feet. What else we got? 14.3 feet. Hmm. 14.3 feet. All right. So let's see if that's right. Yep, I got 14.3 feet as well. So Chloe, what happened? Find your typing mistake probably. Hello? Anybody still there? Chloe, what happened? What was your mistake? I'm just curious. Oh, okay. Yeah, easy mistake, right? Makes sense. Makes sense. All right. Any questions on this problem before we go on? All right. So for word problems, you want to you read through it a couple times, and then figure out. We understand that we're trying to solve for the radius, so that's the unknown, and then you want to write down, what the other information is that's given to you. Yeah, don't panic. And if you want to draw a picture like I did, just to help you visualize it, I think that's really cool too. Okay, on to sector area. So that formula for sector area is this right here, 1/2 times radius squared times theta. All right, so for this first problem here, you're given the radius, you're given the angle, and we have to find the area rounded to the nearest tenth. So we are rounding here, which is kind of neat. So we just plug this stuff in. We're going to have 1/2 times pi, oops, not pi, times 18 squared, and then times pi over 4. All right, everyone, go ahead and type that stuff in and tell me what your answer is rounded to the nearest tenth. We got 127.2, 127.1, 127.2. All right. Antonio, I didn't see your answer. Oh, I did. Okay. Antonio, what was the decimal? Give me like give me like 5 places after the decimal point. You can say it if you could, please.
Oh, my five places. 127.23450.
Oh, you got 2. Is that right, guys?
Yeah, it was two. It's not one.
Okay, so George, how did you get point 1? Oh, you corrected it? Okay, is this a typo? Okay, no worries. All right, just typo. All right, never
Wait,
mind.
sorry. I'm sorry.
Yeah, go
What
ahead.
were the last 5 digits to see if they're the same as mine?
Antonio, type it in chat so we can all see it. So yeah, Caitlin got 127.2345025, 234523450. Yep, and Tony got the same thing. Okay. Yeah, that looks right. Yep, so that is the answer, 127.2. And this is square yards or yards squared. Same difference. All right, everyone, do 7, 8, and 9 on this page. Let's do, I think 3 minutes is enough, right? 3.5. We want 3.5 minutes this time? I feel like there's a little bit more to do. 3.5. Ready to go. All right, when you finish all 3 of them, give me a green check. Don't click the X. Not yet, at least. When you are done with these 3 problems, give me a green check. Unfortunately, once you cast your, I guess, your answer, your vote here, you can't change your answer, which I think is kind of weak. Someone put an X. Araceli put an X. How could you? Put a Naya. Guys, I said don't put an X. I said when you're done, give me a green check. Because once you cast your vote, you can't change it. Hey, don't be sorry. Just don't let it happen again. Right? I'm just kidding. It's fine. You failed me. Okay, now if you are still working on these 3 problems and you are not done, now give me an X. So this tells me that you are here. Looks like Keon's not here. Sad day. Keon, wake up. There you go. Were you still working? Is that why you didn't answer? Type in chat so I know you're here. Okay. All right. Fair enough. Fair enough. I'm the same way. When I'm working on something, I space the entire world out. The house could be burning around me and I wouldn't know because I'm working that hard and that focused. Razor sharp focus. It's probably not. All right. Number 7, what everyone get for your answer? 282.7. 282.7. Lots of those. Ooh, 282.6. All right. George, type in chat what your answer is without rounding. Like, give me like 5 or 6 decimal places. I think maybe George is retyping in the problem to write down what those are. There are no more. That is it. So you just got 282.6, George? Is that what you got? So Michaela, she got 2. Who else got 282.74333 or whatever? Yeah. So we need to figure out why your calculator is giving you only 1 decimal place, because that's obviously not right. You should have like trailing decimals that don't repeat but go on forever, probably. It's Symbol. It's Symbol Lab. Probably, that would make sense actually. Yeah, so maybe use, okay, so that would make sense. Maybe use 3.14. So you don't want to use 3.14 unless the problem says to. So George, did you type that stuff in as you see it on the screen there? What calculator are you using? Okay, that's why. Yeah. So don't. Yeah. So what calculator are you using? Because most calculators actually have a dedicated pi button that you want to use. TI 83 plus. Yeah. So you actually do have a pi button. It's I don't have my 84 here. I don't know what I have. It's in the corner. Too far away to reach. So there is a pi button. You got to hit like second, and then there's like in the bottom right of your keypad. I think that's where it's located. Oh no, it's I think it's on the button with natural log. So if you look at natural log button, I think right above that is either it's blue or yellow key you have to press. I think maybe you want to use that. Yeah, so yeah, use that. So use that instead, and retype it in and see if you get the same answer everyone else did for your trailing decimals, and your final answer should be 0.7. So on your quiz, on your test, sometimes in the modules, it will say use 3.14 for pi. That is the only time you actually want to use 3.14 for pi. Because if you're in the habit of just using 3.14, like for this problem, it actually mattered. You would have been off by 1/10 of a point, which would have been entirely wrong. So keep that in mind. All right, George, you good now? All right. We're on the same page. 282.7. All right. Number 8. What is the final answer for that one? 469.1. Okay, so that's why you did that. All right, you were ready for it. 469.1. I was like wondering. I was like, George, that or who wrote that? Jacob. That's a totally random number. What's going on? Now it makes sense. All right, 469.1. And all of us converted it into radians. We learned our lesson. We are quick learners here. And then that's how you got the answer. And number 9, what did everyone get for the final answer? 16.8. 16.8. Lots of 16.8s. Centimeters squared or square centimeters. 16.8. Ooh. I think it's always great when the entire class gets the same answer and it's wrong. I don't know. It makes me smile. I feel like it's a really good learning moment, right? It's a teaching moment or something. I don't know. 16.8. All right. So we converted into radians and plugged our stuff in, and there you go. So pretty straightforward, right? Not too bad. It scared you for a second. Why? Like this whole lesson scared you for a moment?
I think we like it too when you're wrong and we're all right. It makes me smile at least.
All right. Touche. I like it. All right. All right, Julia, you want to read this one, so go for it, please.
Testing, can you hear me? Okay.
Yep.
10. You have asked your landscaper to create a garden area in an oddly shaped corner of your backyard, regarding the fencing on the 2 sides of the corner as being radii. You walk in an arc from wall to wall 20 feet. The number of degrees walked is 80 degrees. What is the area of the garden? Round to the nearest tenth.
All right. So I'm going to give you all, let's say, I think 3 minutes, 3.5 minutes should be plenty to solve this problem. Ready to go. So remember, our goal here is to find the area. Yep, that's our end game here is the area of that sector. 3.5 minutes. I wish I could read. Oh, don't wait for the breakdown. No, no need to. So if you're kind of scratching your head right now, you need to write down what we know in the problem. Write down what we know. Write down what we're trying to get to. Break it up. You know, sometimes in these word problems, you're not really sure what you're going to do until you start writing stuff down. Maybe when you start seeing what you have, you can kind of work from there. I gave you 2 equations in the top right-hand corner, the area and the sector length. Or the arc length, sorry, not sector length, arc length. You know, I can work with Just keep going. You know, you might surprise yourself. You might know more than you think you do. In fact, you probably do. George sees that. Yep, that is a good observation, George. You know, that means you can basically cut out half the work because we already did it. All right, time is up. I'm just curious. Give me a green check if you were able to finish this problem. Give me an X if you were not. Green check if you finished, an X if you did not. Just super curious. We got one person that hasn't responded back. Let's see who's not getting a point for today. Araceli, you kill me. Where are you? Oh, there she is. All right, so let me just, so you guys can see, looks like 10 of you were able to finish, 6 either still working or just gave up. I like to think you're just still working and didn't give up, because giving up, you guys shouldn't just give up on this. This problem is a lot easier than you think. So 142.8. So Danica thinks the answer is 142.8. Let me open up my I'm gonna look at my actual PowerPoints versus moving stuff around because I don't want to give the answer away. Let's see. One. All right, so let's see. Going back. I think I scrolled too much. So 143.2, 143.2, 143.2, 142.8. Remember, George, don't use 3.14 as pi. That's bad. 142.7. Well, rounded would be 142.8. Let's see. All right, 143.2. So we got a lot of the same answers. We also got a lot of different, another answer. So I do believe that some of you are correct. Let's take a look. So yeah, so what I think was George that said this. This was like the same as the other word problem, but now you're just finding, well, the area, right? And when looking at this problem, to find the area, we need to know what the radius is. We also need to know what the angle is, right? If we have these two things, we could just plug it in and just find the area, right? Well, in this word problem, you are not given, oops, my screen's messed up. Let me go back and then forward. You are not given the radius. You are given the angle, and you are giving the sector arc length. So we couldn't just jump right into this. Because we're missing this, right? We are missing this. So a couple ways to do it. The first way is, well, do what we did in the first word problem and, well, solve for the radius. So once we actually solve this, you can just use that answer and plug it into here, right? Into the second part. And that way works. So, and this is just the same work as last time, right? We found the radius, but you don't want to use the rounded answer. Remember I said you want to use exact work when possible. So we don't want to just plug in that answer directly. Okay, we actually want to use this value for R when you actually plug it into the part 2 of the problem, which is actually just using the sector area problem. Does that make sense? Oops, looks like I got to scroll back down. Here we go. Yeah, you don't round to the end. Yep. Plainly put, you don't round to the end. So if you're somebody who used 14.3 and for your R value and you plug it in to find the area, you might be wrong. You might be off by like 1/10 of a point or more. I don't know. I didn't try it both ways. But for this part 2, all you're going to do is, well, now you're going to plug in the values now, right? So you're going to have 1/2. You're going to have your R is 45 over pi, quantity squared. And then the angle in radians is 4 pi over 9. And then that's how you get 143.2. Did anybody use 14.3 for the R value when plugging into the second part?
I did, and that's why I got a different answer.
Okay,
I got 142.8, and then when I did it the way you did it, I got that answer.
Perfect. And that was my question is if you use the rounded work, R value being 14.3 and you plugged it in, if you use rounded work, would you get the same answer? And sometimes you do, right? And we've seen many examples like on your tests, your quizzes, the modules, practice problems, even my problems. A lot of times you actually do get the same answer, but it's, like in this case, you don't. You use 14.3 and your answer will be off by like a half a point, right? 0.5. So keep that in mind. You want to use exact work. Another way to do this problem, I wish I had more room to write on this page. I'm going to try to fit it. So if you're somebody who likes formulas, we could have actually used this and we could have solved for r. So we're dividing both sides by theta. So r is going to equal s divided by theta here. So that means we actually could have rewritten this problem as a is equal to 1/2 times your radius squared, and we know our radius is equal to s divided by theta, quantity squared, times theta, right? And from here, we could just plugged our stuff in and hit enter. So 1/2 times, your s, you're given s, which is 20. Your angle is 4 pi over 9, quantity squared, and then times 4 pi over 9. Again, we also could have gone one more step in simplifying this formula and said a equals 1/2 times s squared over theta, which is going to be s squared over 2 theta, right? So we could have simplified it down to that, and we would just type in, I'm running out of room. We would type in your s value, we said was 20. So you would say 20 squared divided by 2 times 4 pi over 9. Oh. Okay, I'm out of room to draw my last parentheses. So everyone type in 20 squared divided by the quantity 2 times 4 pi over 9, hit enter. And no surprise, as long as my math was good and I didn't mess anything up, we should get 143.2 again. Do we? Yep. So we get, okay. So some of you tested it. So yeah. So we get the same answer. So guys, there's more than one way to approach these problems. You can do it like we did at the start of this. Do it in 2 parts, right? Or you can use the formulas and manipulate them and plug stuff in to simplify your formula, like I did, to get s squared over 2 theta equals area. You do it that way. So it's it's however you see it. There's more than one way to do a lot of these problems.
I actually did it even a different way, but I don't know if all calculators allow for this. So I typed in the first part, the 20 divided by 4 pi over 9, and then got the answer on my calculator, and then I just did answer squared using the answer key, and then did that answer times 1/2, and then did that answer times 4 pi over 9. But I
Perfect.
don't know if all calculators have that option, but that's how I did.
A lot of them do. Like my FX series has it. I know like the TIs have it.
I'm using the FX 115 plus.
Yeah.
So I did it.
You can also so when you get answers, you can actually store them. Like your TIs, they have a store button. You can actually store them as a certain variable. So you can actually, once you get your answer, put store X, and it saves the exact value in that variable. So then for your next step, kind of like what Emily, was that you talking?
Yeah, that was me.
Okay. You can in your next step, like she did, you can then put like 1/2 times like x squared, for example. The fx, I never used it, but I'm sure it probably has like a store and a variable option that I just haven't used before on that calculator. But those are more advanced options and
Yeah,
features
I've
that you can use.
used it.
Yeah.
It has
Yeah,
an X key that you can do, and then you just type the X in and solve, and it works.
Yep. So people who use like next year, the people who are going to your next math class, whether it's you're still in high school or you're going to college, and when you actually learn how to use your graphing calculator properly and use you graph stuff, and you also use the feature of storing variables numbers into variables, you kind of want to avoid using x and y because when you graph stuff, it uses those same variables, and anything you store into like say x or y will get replaced when you graph something. So kind of a little caveat you got to remember. All right. So, that's all I really got. My final thoughts here is, make sure when using these formulas that it is in radians for your angles. That is huge. Other than that, guys, well, thanks for coming, and I hope you learned something.